Hello, everyone, to like 30-minute rant about why Kubernetes is slowing engineers down, and hopefully, some hints on what we can do about it, and getting to the root of, what is actually slowing folks down. I'm Lukas. I'm the CEO at Loft Labs. We started the company essentially to bring virtual clusters to the masses. I think Rich, my colleague, and Carl, they both have given a talk yesterday about virtual clusters. If you missed that one, definitely make sure to watch the recording. Everything we do on the commercial side is based on our work in the open source space and the great work that we do with our open source users and our community. Two of the projects that have been very popular are vCluster, which is essentially a foundational technology for creating virtual clusters. Amazing, adoption in the community. We launched a project 2 years ago. And the first, we launched it like around March, so the first 9 months or so, we saw like 1 million virtual clusters created, and that was already an insane number for me at the time. And then last year, we actually saw 25 million virtual clusters created out there, and I'm like, oh my gosh, it's blowing my mind. In this January, so just last month, we saw 5 million virtual clusters created. So we're very likely gonna, cross the 100 million virtual clusters sometime this year, I guess. And super, super exciting. If you don't know what a virtual cluster is, it essentially allows you to spin up a, Kubernetes cluster inside of a namespace of another Kubernetes cluster. Sounds kind of weird. Why do we need that extra layer? But it really makes things a lot easier in terms of like sharing a Kubernetes cluster, multi-tenancy, sharding the Kubernetes API server if you're running it at scale, and it saves a ton of cost, right? If you're spinning up, 50, 100, some of our customers spin up thousands of Kubernetes clusters internally to hand them out to their engineering teams. It is obviously very preferable to kind of consolidate things into fewer clusters because you can share things. Just think of things like, Istio, all the like storage, monitoring, logging, OPA, all of these things are repeated in each cluster. So essentially having fewer clusters and then creating these virtual clusters inside of them is much more efficient because you can share the underlying, platform stack, monitoring, logging, etc. All the virtual clusters can use them. And then essentially, the developers and the engineers work in the virtual clusters and they feel like the admin, right? It's kind of like a VM. Inside, you're the king, right? And outside, you're kind of restricted. That's what vCluster is about. And DevSpace is actually a project we started a couple of years beforehand. And it's an open source project as well as a developer tool for Kubernetes. And that's more of where this actually talk is heading towards. When we're talking about Kubernetes and developer efficiency, I think it's super helpful to kind of go back in time and see what did we actually do before Kubernetes. If we're going back 10 to 15 years, everybody was kind of like on the Ruby on Rails hype train, right? Like everybody was riding the Ruby train, and that was great, right? We're happy with having that Ruby application being deployed on Heroku. That's kind of how things like GitLab and GitHub and even companies like Gusto outside of the tech space got started. And it worked great because it's quick, right? You're building this monolith. If you essentially want to spin up that application as a developer, well, it's super easy to do that. Rails server, right? 2 words to remember is to start this thing up, right? Git push Heroku main, or I guess back then it was more like git push Heroku master. Is to push it to Heroku, and then you can run things like Heroku logs, or you can run commands like Heroku open to essentially get some kind of subdomain, access it, share it with your front-end developer who needs to access your API, right? Really great experience, super simple, right? That's like 10, 15 years ago, and a lot of companies have started that way in the tech space. But, the ultimate result of this is 10 years later, after these companies have been, massively scaling up their engineering teams, massively scaling up their user bases across the globe, right? The sentiment kind of is like, monoliths suck, right? We need microservices, we need to scale out, we need Kubernetes, right? We need containers, we need to split things up. And that makes a ton of sense because when you're thinking about monolithic, monolithic Ruby Rails application, it's essentially, it's essentially very tightly coupled code, right? Everything we're building there is very tightly knit together, and that's a huge problem because that leads to kind of dependency hell inside of the application, right? If you have a system that's as big as something like GitLab, right? It's really hard. I mean, they did an amazing job at actually keeping their release speed up very, very highly, right? With their monthly releases. But a lot of companies struggle to do the same thing. And it's really, really hard to do that with such a tightly knit code base. And applications like that are inherently centralized, right? So you may run into scaling concerns. Not every, every application is going to face that, but certainly, the GitHubs and Gustos of the world are, because they have users everywhere, right? They need to distribute the applications. They need database sharding. They need a lot of things, right? And a centralized application obviously can't fulfill these things very well. And then upgrades become very complex, right? Essentially, releasing new code is super difficult because, we have a monolithic application. So the risk of something going wrong affects the entire system rather than just a little piece of it. So essentially, we're slowing down the release cycle in a lot of cases. So, Microsoft and microservices, or definitely not Microsoft, but microservices and Kubernetes for the win, right? We need that. But the problem is, it's really slowing us down, and a lot of people are seeing that today. If you're thinking about, engineers directly working with Kubernetes, deploying applications to Kubernetes, there's a lot involved. So, oops. It essentially starts with images, right? The first thing you need to do is build images, tag images, push the images to a registry. Now you need credentials for some kind of registry to push them to. Then you need to deploy. Now you got to know, besides having a Docker file, now you also need like a Helm chart. You need a customization. You need to know what a Kubernetes deployment is and what a Kubernetes service is, and you need to wire up everything. Engineers need to know what Helm upgrade is or how to deploy a customization. And then ultimately, now we want to expose it, right? It was just like Heroku open, right? That was 2 words to remember. Now we got to actually find out, what did we deploy here? We need to get the pod, right? I need to find out, because it's not like Kubernetes deploys us like this API, right? And I can say, hey, kubectl logs API, right? That's just not how it works. Kubernetes doesn't know what is this API, right? The Helm chart may be called API or authentication service or whatever it's called, but it's going to create a deployment, it's going to create a service, stateful set, etc. And these are creating replica sets, and then they are creating the actual pods in Kubernetes, which then host the containers. So we need to find out what are they called, right? And we can do that with kubectl get pods, and then we can finally do like port forwarding. And then the reason I drew this arrow here is, well, we make a change and we want to see if things work now, so we have to do everything all over again, right? It's a pretty annoying process, and that really slows a lot of folks down. Of course, you can automate these kind of things in CI, right? You can say, hey, we'll just bake this all into GitHub Actions. But then what we see a lot of engineers do is kind of this like, I call it like the abuse of the CI pipeline, right? It's kind of like, I can't test it really locally. I can't run these integration tests locally anymore, right? With my Heroku Rails application, I can, right? I can deploy the Heroku myself very quickly from the CLI. I can run tests against it, right? And I can see what's wrong and fix it. If I'm now baking all of this into GitHub Actions or GitLab CI, the engineer is going to continuously, git commit, git push, right? And that's a very slow workflow because you also now need to optimize your pipelines. By default, your pipelines are not going to cache anything in between, right? So it's very, very slow. And CI minutes are kind of expensive compared to actually building an image on your laptop and running it there. So really resorting to this workflow is not great. Automating the same thing with CI is not great. there's really not a great solution for this dilemma. So how about PaaS, right? PaaS is the solution for everything. It's been the solution in 2007, and it worked great for these companies, right? Essentially, people discover that every about 4 years or so. It's very interesting. It has this interesting cycle, and I kind of drew that on the slide. 2007, everything was about Heroku. That was obviously the developer's favorite that came out, blew up, right? And then Google also launched App Engine as obviously something they wanted to push forward. Cloud Foundry, came along a couple of years later, trying to standardize things for the enterprise, doing it open source rather than, obviously Heroku was a commercial product or is a commercial product. And then AWS launched Beanstalk as another alternative PaaS solution. And then, the container wave started happening. And the first approaches towards let's run containers were actually PaaSes as well, right? They were essentially, when you're thinking about .cloud and Tutum, one of the earliest companies that kind of ended up as the first engineers working at Docker and building those amazing technologies down the road. And I think it's very interesting that we kind of resort to this, like, we need to build a platform, right? As an engineer, we see the problems, so we're like, we need to build a platform. That's the answer, right? And then last but not least, to just add the more, I guess, Kubernetes native example, a more recent example here as well. Google with Cloud Run essentially launched a PaaS as well that is connected to obviously Google Cloud, going back to like proprietary solution again, building on open source, but being container native, unlike a lot of other solutions. It's very, very interesting. We see that cadence, right? We see a lot of these PaaSes coming out. And what people usually see after the initial hype of a PaaS is it's not the silver bullet, right? Essentially, 1 or 2 years later, everybody is like, oh, this PaaS is like super inflexible and is super limited. In the beginning, everybody loves it, right? But then, 1 or 2 years later, everybody starts to hate that PaaS, right? Everybody wanted to migrate off Heroku. It was inflexible. It was a lock-in, right? It's very, very interesting to see. It's a cycle. I don't know how long it's going to repeat, but we've definitely seen it a couple times happening at this point. It's very, very interesting. I think, actually one of the strengths of a PaaS is that it's opinionated. The person or the group or whoever is building that PaaS is coming together to decide, okay, we have certain ideas and best practices on how to do things. How can we make that accessible to a broader audience, right? To someone who is not as experienced and deep into, Kubernetes or back then Rails with Heroku as we are, and we can help them run it as nicely as we can run it manually, right? So it's inherently very opinionated, which is a strength because that's what makes a PaaS so simple and so attractive, and that's why you love it in the beginning, right? But ultimately, you're limiting users' choices, right? Because you're saying this is the golden path, and this is what you should be doing. And then, users are hitting these limits, and you start to add these like, oh, we're adding this option and that option, where you can kind of tweak these things, right? And then it gets similarly complex again if you do that, if you're even able to do this. A lot of PaaSes, don't even go that far. It's a pretty big advantage and at the same time a challenge for PaaS to be opinionated. And PaaS kind of means magic, right? I'm running Heroku push, right? I don't know what's going on, right? It's like, it's some kind of magic that is going on the Heroku side to actually get my application up and running. I run Heroku open. Do I know if there's like a load balancer provisioned, DNS entry set? I don't know, right? It's very, very interesting that a PaaS is a lot of magic, and that's actually a huge benefit as well, because it makes things easier for the developer, right? They don't need to think about what's happening; it just happens, right? And if that works, it's great. The problem is, if it doesn't work, it really obstructs people digging deeper, right? Because sometimes your application is just not suitable for that particular PaaS and may not run very well there, and you may need to change something, right? But you can't, and you don't really know what's going on. That's a big problem of a PaaS, using too much magic. And then last but not least, PaaS is ultimately abstractions, right? It's layering and layering and layering, and that creates a lock-in because we have some kind of opinionated way to do things on top, right? Rather than actually giving us deeper level access to, the containers or whatever the PaaS is spinning up under the hood. And that makes it so hard to move away from something like Heroku, right? And a lot of companies obviously had to go through that cycle. When we're looking at Kubernetes now, right, it's complicated, right? So PaaS is obviously not the great solution, but still, Kubernetes is pretty difficult. It's not our, solution towards deploying applications simply, right? That's not really what it was intended for. But Kubernetes has some interesting approaches that are, again, benefits and at the same time downsides. It gives you endless choices, right? I mean, I don't need to pull up that landscape, right? You're going to see it in every second talk about Kubernetes. There's a bazillion tools on there, right? And that's actually really great because it gives you choice. But at the same time, there's a lot of FOMO, right? There's like, Knative is just being hyped, right? Do we need to rewrite everything in Knative? It's very interesting. There's always a hype cycle. We see the same thing with vCluster, right? vCluster's coming out. Everybody wants to do everything with vCluster right now. Obviously, you should, right? Because vCluster is awesome. But, it's definitely a hype cycle, right? There are some cases where vCluster makes a ton of sense, and there's probably cases where it doesn't, and you should use it where it does make sense, right? And that kind of FOMO, I need to jump on the next tool that comes out, is actually keeping us from doing something productive a lot of the times. At the same time, you're kind of reluctant to actually make a bet on a technology if there's like 20 options, and you don't really know, right? You're looking at them, and you're like, which one are we supposed to pick, right? Because ideally, we want to use this for the next 5+ years, right? But maybe this project's not going to be around for a year. I don't know, right? Which one of the is Istio going to win? Is Linkerd going to win, right? It's kind of like, a lot of people are looking at it that way. I don't think that's a way to look at it. I think there's a coexistence for a lot of these projects, and there's a very valid reasons why there are multiple alternatives. But in a lot of cases, that is actually, people are holding off on just rolling with something because they're kind of reluctant to make that decision. I tried to find a fancy word for this and started Googling, and apparently there's this decidophobia, which means you're too afraid to make a decision, so that you're actually holding off on it for a while, right? New term I learned. I'm not sure if you knew about that before, but decidophobia and FOMO are definitely a real thing in the Kubernetes space. So having endless choices is great, but it can lead to some problems as well. Kubernetes is very explicit, and I consider that a big strength of it, because Kubernetes is not really, a ton of magic in the sense that, there's like readiness probes and liveness probes, and like everything is very explicit, right? You define everything specifically. I don't think anyone has done that for Heroku, right? What is the readiness probe in Heroku? I don't know, right? There's something in place that they probably put in place, but that's the magic part, right? Kubernetes is incredibly explicit. There's still a lot of stuff that happens under the hood, but almost everything is exposed, right? Almost everything needs to be specified. Not a lot of things are like default on and assumed, right? There's no readiness probe by default, right? You kind of have to set that up and essentially define it in your YAML files. And that's a big strength, in my opinion. But it also leads to that YAML hell, right? Everybody knows, 1,000 lines of YAML code is really hard to read and maintain. And, when you're thinking about individual developers joining a new team and, they're going through that code base and they're like, gosh, what is this doing? Like there's so many new Kubernetes options coming out as well that it's super hard to keep up with all of the, explicitness. And Kubernetes is very composable. And that's great because, your application may be a simple, 3-tier backend, front end, and some kind of data layer application, but it may be more complicated, right? And you can design all of that in Kubernetes however you want it, right? Services, stateful sets, the decoupling of things, right, makes a ton of sense in Kubernetes. But that composability is also very complex. because I don't just have like my app API, right? And it's 3-layered, and that's just what it is, or 3-tiered. It's more complicated than that in a lot of cases, and that flexibility is actually hurting quite a bit. So if you ask me, what is the right answer to actually overcome these issues? In my opinion, it's transparent abstractions. Transparent abstractions allow us to create something on top of Kubernetes without actually hiding Kubernetes from the end user. In my opinion, that's different than a PaaS, because a PaaS creates this layer that is not really see-through, that is not really accessible, right? I argue that we should actually have transparent layers on top of Kubernetes and don't take Kubernetes away from everybody. In my opinion, you can achieve this by creating something client-only, and I threw in there CLI first, right? Because working in the CLI terminal is super straightforward, right? You see that the success of Heroku as well, right? Being client-only means there is no server magic going on. It's a translation of everything I do is going to be translated to something that I could also do with kubectl, right? By being client-only, I achieve that. If I have some kind of server in the middle that I now send some kind of GraphQL request to, right, and somehow that ends up somehow in Kubernetes, there's some magic happening there, right? If I'm in a CLI, there's a lot less surface area for magic to happen, and at the same time, you can still create a very efficient experience. In my opinion, you need to make sure that whatever this layer is, that it's very customizable and very extendable. Because essentially, when you're building an abstraction layer for, within your company, first, you may be using different technologies within your company, right? There may be, 3 different teams working on different things, and nobody can define the golden path for, everybody at the same time. So there needs to be some common ground, and then a ton of flexibility, so everybody can essentially optimize for their specific scenario. And last but not least, I think strictly being based on the Kubernetes API is very important. Again, like not having a server-side component that does any kind of like translation and magic, but rather saying, hey, like I showed earlier, right? We need 5 kubectl commands to actually do what we want to do. How can we just automate that, right? How can we bake it into one command that is easier and skips a couple of steps, but essentially, can be translated to Kubernetes API server requests? I think that is super important. So the question is obviously, what is the best tool? And as we discussed earlier, for each category, there's always one best tool, and it's gonna win and succeed, right? No, obviously that's not the case for this category as well. That's why I'm essentially showing you a variety of tools here. And obviously, since we're building the tool dev space, I'm going to demo that in a couple of minutes to walk you through how the experience looks there and explain a little bit on, what happens under the hood. But any of the tools in the space will do, right? And there may be tools that are better suitable for your case than DevSpace. So I just urge you to check all of them out. There's essentially 2 buckets, and I'm glad we made the jump from one bucket to another one very recently with DevSpace. The first bucket is CNCF projects. There are essentially 2 projects in CNCF Sandbox that are very exciting to push on developer velocity, developer experience with such a transparent layer approach rather than creating a PaaS offering. The first one is telepresence. They've been around forever. I think they started like 4 or 5 years ago, that project. The idea is essentially that you deploy your application somehow via GitOps, via Helm CLI. It's not very specified. But then you start part of the application locally. So let's say you have a microservice system and you have like 4 microservices, right? And they're deployed via Argo CD. And now, as a developer, on every branch, essentially deploying into a different namespace, for example, right? And as a developer, I now get access to that dev cluster to my specific branch, right? What I want to do is I want to skip all of this like image pushing, having to put to Gish, going through the CI pipeline. I just want to debug one of these microservices. I want to see what if I make a change here, does it still work, right? I want to run these integration tests. I want to be as close to Kubernetes as possible, as close to the real, EKS environment as possible. So I'm deploying that application, then I spin up telepresence to essentially do some network magic. What they're doing is they're deploying something very lightweight in that namespace, and then they're connecting the local environment to the other services in that namespace, so that I can run one service locally, or potentially also 2 services locally, right? And that's the ones I can start hot reloading, my debugger, right? They run locally on my laptop. I can debug them with my IDE, just a regular process. But when I do a network request to service B and C in my microservice system, then I can talk to the real services running in production mode inside Kubernetes. Obviously, very, very useful. Very quick cycle, because we don't even need to build images for any of this, right? Because we're running that one service locally now, so we can just start it in dev mode, right? We can have different settings, etc. The part where it gets a little tricky about telepresence is if you need to mount like a config map, or if you need to attach a volume or something like that to the current service, right? Obviously, your local laptop can't mount really easily a volume from your remote Kubernetes cluster and pull the data from there. So you have to, potentially, work around these topics. They have some solutions for that, but they're having pretty big constraints in terms of operating system, right? Some things work pretty nicely. Obviously, everything works always great on Linux, right? Especially, if you have like one of the popular distros. And then on Mac, obviously, you can make it work. And then on Windows, it's like, ooh, that's like danger territory, right? It's like where it gets very tricky when you're talking about, volume mounts and stuff like that. And then, the other solution that's in CNCF is DevSpace, right? You can see I'm obviously biased. I've been, one of the maintainers of DevSpace since 2018. Because we saw this problem, right? We essentially, at the time, not a lot of people were considering Kubernetes to be moving towards individual developers and dev teams. The first talk I gave about DevSpace was at a conference in 2018, and there were like 4 people in the audience, right? And people were like, no, that doesn't make sense. Kubernetes for production, right? Like, we don't care about this tool. Was very interesting. I think that mindset has changed, which is great to see. We made a lot of progress since 2018. And I think a lot of people realize that we need to kind of shift things left and essentially start earlier with that access to Kubernetes, facilitating things and kind of parity between dev, staging, prod, etc. And DevSpace is a great tool to help with that. Unlike telepresence, with DevSpace, nothing runs locally. The idea is we move the runtime towards Kubernetes entirely, but we're skipping the image building part, and we're connecting your local, file system and ports and all of these connections with that remote container. So the way this works is by essentially launching a container that is modified, right? And that can be a pre-built image. A lot of companies who use DevSpace either use our pre-built images. We have one for each language that is equipped with some standard tooling, or they're building their own images, and every time something gets merged on the main branch, they update that dev image, right? So they have a separate Docker file that defines, okay, our dev container looks like this, right? It has this tooling in there. Obviously, it's different than your production container. Your production image may be distroless, right? Has a single binary in it. There's not a lot to do with it, right? Like, you can't really develop in that. But your dev container may look a little different, right? And DevSpace allows you to stand up your 4 microservices, and then you define this microservice, which I'm currently inside of the Git repository on my local file system, right? Should be stood up in dev mode. And that means instead of launching the production image, we're swapping out that image with a dev image. Then we're connecting the file system in terms of we're syncing either source code, if you have something like PHP or Node.js that doesn't need to be compiled, or we can even sync compiled binaries, right? And then essentially hot reload that container without having to restart it, rebuild images, etc. And that means you can code in your local IDE, you can attach a remote debugger, you can program in that IDE, but you can access things on localhost because it starts port forwarding similar to telepresence. And every time you change a line of code, your application updates inside the remote container. It means you get the same experience as with telepresence, but we also take care of this deployment part in case you don't have these pipelines set up, an Argo CD set up to deploy on each branch, etc. You could do that with DevSpace as well and disable that part. But by default, you're also including the Helm deploy, customization deploy, right? And then we do that hot swapping of these particular containers. And that creates a really efficient dev experience. And again, there's a whole bunch of other tools. There's Scaffold, which a Google team is working on. There's Tilt, which recently got picked up and acquired by Docker. And unfortunately, that made the project a little quieter. They were actually one of the, I think, obviously DevSpace is the best solution. But in my opinion, Tilt actually did an amazing job at building the project. Unfortunately, it slowed down a little. And then there's Octador and Garden, two other startups who are building projects out there. And I could probably add another 20 on this slide, but then things would get a little small. So I just listed the ones that have 2,000 plus stars and are pretty popular in the space and have been around for quite some time. So we know they have active user bases, active Slack channels, right? So whichever tool you pick and just check out all the tools, test them, verify them with your team, see which one works, and then don't have the decidophobia. Just run with one that works, right? Improve your workflow. It's CLI only, so it's pretty straightforward to switch tools as well. And that being said, this was the last slide, and I can walk you through a DevSpace, a tutorial real quick, just to see the experience. Takes about 2 or 3 minutes, so you can get a first glimpse on, how does the project work, and then maybe we have another couple minutes for questions. All right. So. Let me go to VS Code over here. So I already checked out our Golang Quick Start project. It's very simple. It has a Docker file already in there, pretty straightforward. Essentially it's just adding the work directory here, building a Go binary, right? And then essentially, running Go run, pretty straightforward. We have a single main Go file here, which essentially just spits out some HTML code, very, very simple. If I want to run this now, and I do have Docker Desktop running here in the background, so I should be able to run, kubectl, get pods and stuff like that, right? And kubectl get namespaces. I can now essentially use vcluster to get a fresh virtual cluster, because I don't want to mess up my Docker Desktop Kubernetes cluster. I just got that one, right? So I need to reset it every time I try a stupid operator and it doesn't work and messes up my cluster, sets a ton of finalizers. I can't delete that namespace anymore, right? All of these issues. So I'm just going to run vcluster create demo, which is now spinning up a virtual cluster. And that virtual cluster is essentially just a container, right? That runs in a namespace. So we see a namespace in our underlying cluster, and inside that namespace, there's a control plane being launched, which is essentially just a single pod with a syncer in there and with the API control plane in there. It's a separate data store from the underlying cluster. So whatever I do in the virtual cluster doesn't matter to the underlying cluster, except for the pods. You'll see them in the underlying cluster. So now we have a virtual cluster, and you can see we're already connected. We can disconnect now to revert back to the original cluster's context. But in this virtual cluster, I can now run kubectl get namespaces, as I just did. And you see all of these namespaces, default, etc. They're only 35 seconds old, right? Because we just created that cluster, right? And after we're done with this demo, I'm going to delete it again, and the cluster is clean, right? Nothing remains in my underlying Kubernetes cluster. We're inside this project, and now we want to test DevSpace. So I'm essentially going to run DevSpace init here to initialize DevSpace, because again, you see this project is super straightforward, right? It's got a Docker ignore, some Git attributes file, a Docker file, a main Go, right? 4 files, right? That's a project. I first need to initialize it. So DevSpace is going to ask me, what's the programming language? It already sees there's a Golang file in there, so maybe Golang, right? So I'm selecting that one. It's asking me how to deploy this. In this case, I'm choosing Helm, but if you already have like, Helm chart in there, obviously select Helm as well. If you have manifests, select kubectl. You can also skip this entire process and create your own DevSpace configuration. This is really just to kind of boost, quick start the experience to set up the initial config. Then it detected, hey, this is a quick start project, so I don't need to ask you 5 more questions. And we can just say yes, right? And it's just going to ask the very core questions. The first one is, do you just want to deploy this project or do you want to develop it, right? And we're saying, yes, we want to develop it. This contains the source code. It's asking where's the Docker file, and it already found one on this path. So we're just confirming. It's basically just enter, enter, enter for now. And it saw we are already signed in with Docker Hub. So we could use Docker Hub as image registry. I'm just confirming that as well. But we can even live without an image registry because, again, we're using that hot reloading mechanism, right? It's just like DevSpace wants you to configure it like end-to-end, right, to set it up if you want to potentially use it in your CI pipeline later to spin up review apps, etc., right? But in this case, we're skipping this. And we have this DevSpace YAML file here now, which essentially defines how this project is deployed. It's a pretty straightforward file. It's very readable. You say like, oh, these are my images, right? My deployment is a Helm chart, right? And we're using this Helm chart, which is a Helm chart that DevSpace provides. It's a very straightforward, customizable Helm chart. But you would just provide your own or folder wherever your Helm chart is, right? You provide some values here that may be overriding your production values or your standard values in your Helm chart. And then it's configuring the dev mode, telling us which ports to forward, which folders to sync, and how to do the hot reloading, right? And if we want to fire this up, the only thing we need to do is tell DevSpace which namespace to use. Because again, we're in a virtual cluster now. We would deploy the default namespace. I never deploy the default namespace. You can with DevSpace. It's going to show you a little warning and wait for 5 seconds if you want to do that. But I usually don't. So let's call this namespace demo. And then run DevSpace dev, which now is going to, again, tell us what it's doing under the hood. That's what I mean with transparent abstraction, right? We tell it, deploy this Helm chart. Well, that's kind of a Helm install command, right? Then we tell it to sync code. That's essentially kubectl copy, right? There's a command for that, right? And then ultimately, last step is it opens a terminal, which is kubectl exec, right? That's what we defined. We could also say our application starts a hot reloading daemon inside of the container, and it would stream the logs instead of opening the terminal, right? There's a lot of flexibility on what you configure in that DevSpace YAML. And now I'm inside the remote container, right? Well, it's on my local machine, right? But essentially inside the Kubernetes cluster, whether that's EKS or local, doesn't matter. DevSpace just needs a kube context. It doesn't need anything remote. It's not a pass, right? There's no server. Everything happens locally. Everything is translated to kubectl command ultimately. And again, we have kubectl exec running here, so I can run kubectl go main go to essentially start this application. Because one thing that our dev image typically does when you opt for the route of using the CLI and opening a terminal rather than streaming the logs is we override PID1. So your application is not running yet because you want to run it yourself, right? Which allows you to kind of see the logs immediately, be able to restart it. And we see here this is our application, right? Very straightforward. It immediately opened it because it knows the port that we configured in port forwarding. It kind of saw, oh, there's something available now, so let me open the browser and show it to you, right? And now I can make changes. So if I go to my Golang file over here, my main Go, and it says like, now it's time to code, and I'm going to add here with Kubernetes, and I'm going to save this file, right? I'm going to abort. It's very nice. It's the same experience as I would do locally, right? I make a change, I abort my command, and I just type up and enter and rerun it, right? Very straightforward. And then I switch back to my browser, and you can see the change takes effect immediately. So we're running inside Kubernetes. We can connect to other services. We can mount volumes, config maps, etc., and have a very nice experience that feels kind of like localhost, but actually everything happens remote. And there's also a mode where you can connect directly to the container, that even on the left-hand side of file system and the entire terminal, everything would be remote. We're connecting into the container via SSH and VS Code's remote extension. It's a very nice experience as well, and that even allows you to set breakpoints for debugging, etc., and get an even better experience. And again, since this is a virtual cluster, I can just go outside of the container here, and I can run vcluster disconnect to go out of the virtual cluster's context, and I can run vcluster delete demo, and that's going to delete my virtual cluster, and it was if nothing ever happened, right? And that's the end of the talk and the demo. I hope this was helpful and interesting. If you have any questions, I'm going to be here for another 5 or 10 minutes or so. Thank you.
Do we have any questions?
Hey, we're just wondering, what's the advantages of using a virtual cluster versus just having a separate namespace? Is it just the sub-namespacing, or?
Yeah, so the advantage is you can clean it up just like a namespace, right? In this localhost scenario, if I was going to use my Docker desktop, and let's say it was a little bit complicated application, not just like the one I just deployed, it's like just the one deployment, right? Mm-hmm. But if I have an application that runs in 5 different namespaces and installs the operator, right? Like a lot of things can go wrong in that cluster and actually mess up your cluster. Do you really want to mess up that cluster, or you want to work on a virtual cluster, right? The other thing is you can actually run the command vcluster pause, because this is on my local laptop, right? Or even if it's even worse if it's in EKS, right? Because money to run stuff there, right? Usually I want to turn my dev environment off when I'm not working. So my fan goes off or my EKS bill doesn't go up like crazy. So I can run the command vcluster pause, and vcluster pause pauses the entire virtual cluster and everything that's in there. That means the state is there, persistent volumes is there, all the configuration is there, but no containers are running. That means your Docker locally is going to not run any containers, and your fan is not going to go crazy. And in EKS, your cluster is hopefully going to scale down when you pause the virtual cluster.
Yeah, thank you.
Hey, I will also add that sometimes you have cluster-wide resources, and also deleting a namespace not always works for some reason. I have a question for you, Riga. So 2 questions. You have to exit the vCluster first before deleting it. If you try to just delete it, it doesn't do both.
No, it wouldn't do anything. I mean, it would tell you I can't find that particular vCluster,
Oh, because it doesn't see the current cluster it's in. That's what you're saying. Only the right. Inner clusters.
Not sure if I understand that question.
I'm saying because it doesn't see the current cluster it's in, only the nested or the inner clusters.
Yeah,
that's what you're saying.
Yeah, when you're inside the virtual cluster, you're talking to the virtual cluster's API server, so you have no access to the underlying cluster.
Okay, only the host. Yeah, okay.
Yeah.
Got it. And the other question is, what if you make changes to the Docker file? You have to, adding a new port or whatever, you need to exit, restart? Well, how does it work?
That is unfortunately the case. It's very quick to do that because when you abort devspace dev and then you change the file and you run devspace dev again, I mean, you saw it took 10 seconds to connect, but it even is going to be quicker because it won't need it's going to run Helm install. That Helm is going to tell you, well, everything's already there. So that command takes half a second, and then it's immediately opening the terminal. So that would be super fast. But we did have requests as well that do that hot reloading as well. The kind of can't you just in the background add another port forwarding command or remove it, etc. by watching the devspace YAML file. We're thinking about that, but it's a lot of work, so we haven't done it at this point.
Yeah, I mean, you have good guys, so they should be able to. And other question, you were talking about breaking breakpoints. You were talking about telepresence at that time, or you were talking about devspace as well? When you mention it.
So if you have VS Code, but also IntelliJ, it works the same way. You can connect to a remote container via SSH. So if you have a SSH server inside the container, which devspace actually injects for you, if you set the SSH true config in the devspace YAML file, and then you can connect your VS Code to that SSH server, and then on the left-hand side, your files are going to be automatically the remote files. Your terminal is going to be the remote terminal without running any dev space command. And you can set breakpoints immediately because the Golang or Python or whatever application actually runs in that SSH context directly without this like sync and proxying. So you in your terminal, you can, in your IDE, you can directly debug essentially. Cool. Thank you so much. Enjoy the rest of the conference and the